Today, I'm going to focus on the math section of the SAT. So, I'm going to go over 6 lessons. The first lesson is on algebra, solving equations, evaluating functions, including composite functions and multivariable functions. And then we'll move on to lesson 2, converting sentences into equations, including solving a series of word problems. And lesson 3, ratios, proportions, probability. Lesson 4, averages, fractions, percentages. Lesson 5, graphs of linear, quadratic, and absolute value functions, including slope, arithmetic, and geometric sequences. And then lesson 6, a review of geometry. Now, in each of these lessons, I'm going to start out with a review of the important topics, equations, and concepts that you need to know. And then we're going to work on a series of multiple choice problems. Now, for each of these problems, I want you to try to solve it first before looking at the solution. So make sure you pause the video, do the problem first, and then check your answer by unpausing the video and watching the solutions. This is the best way to get the full benefit from this video if you want to do well on the math section of the SAT. So, let's begin. Let's start with the first lesson on the algebra part, on solving equations, evaluating functions, factoring, and things like that. Let's go over the basic concepts that you need to know, and then we'll work on a few multiple choice problems. So let's start with exponents. When you multiply common bases, you are allowed to add the exponents. So x cubed times x to the 4th power is x to the 7th power. 3 plus 4 is 7. Whenever you raise one exponent to another exponent, you can multiply it. So 5 times 4 is 20. And whenever you divide one base by another common base, you can subtract the exponent. So 9 minus 2 is 7. Now, let's say if you have a radical, the cube root of x to the 5th power, how can you convert that into a fractional exponent? This is the same as x raised to the 5/3. So likewise, let's say if you have the 7th root of x to the 9, you can rewrite this as x raised to the 9 over 7. Now, let's say if you wanted to evaluate 4 raised to the 3rd power. What does that equal? Now, 4 cubed means that you're multiplying 3 fours. 4 times 4 times 4 is 64. Likewise, if you want to find the cube root of 64, you need to find what number times itself 3 times is 64. So what times what times what is 64? Which we know it to be 4. So let's say if you want to find the 4th root of 16, what times what times what times what is 16? This is 2, because 2 to the 4th power, which is 2 times 2 times 2 times 2, that's 16. Now, let's say if you wanted to simplify a fractional exponent. Let's say if you have 8 raised to the 5/3. How can you find the value of this term, or of this number? What you could do is you can separate the fraction into two numbers. 5/3 is the same as 1/3 times 5. So 8 raised to the 5/3 is the same as the cube root of 8 raised to the 5th power. 8 to the 1/3, or the cube root of 8, is equal to 2, because 2 times 2 times 2, 3 times is 8. And now we want to find out what 2 to the 5th power is. So 2 times 2 times 2 times 2. 2 times 2 is 4. This is 4, and this is 2. 4 and 4 is 16, so 16 times 2 is 32. So 2 to the 5th power is 32. Let's try another example. So let's say if you want to find the value of 16 raised to the 5/4. The first thing you want to do is find the 4th root of 16, and then raise it to the 5th power. The 4th root of 16 is 2, and 2 to the 5th power, we know it to be 32. So let's say if you want to solve an equation that looks like this, x raised to the 2/3 is equal to 16. How would you do it? In order to solve for x, you need to convert the exponent from 2/3 and change it to 1. The only way you can do that is to raise both sides to the 3/2. 2/3 times 3/2 is 1. And so we got to find out what 16 raised to the half raised to the 3rd is. 16 to the half is the same as the square root of 16. and the square root of 16 is 4. And 4 raised to the third power, we know it to be 64. So now let's say if you have a square root, the square root of 5, and you wish to square it. What is this equal to? The square root of 5 squared is 5. The square and the radical cancels because the index number is a 2. It's always assumed to be a 2 if there's nothing there. You can also see it this way. The square root of 5 squared is basically radical 5 times radical 5. 5 times 5 is 25. And the square root of 25 is 5. So if you were to see the square root of 8 squared, this is simply equal to 8. Now let's talk about the absolute value. The absolute value of a positive number is a positive number. The absolute value of a negative number is also a positive number. So with that in mind, how would you solve for x in this equation? The absolute value of x plus 1 is equal to 3. So what's the answer for x? Whenever you have an absolute value equation, you need to write two equations. X plus 1 can equal to positive 3, and it can also equal to negative 3, because the absolute value of 3 and negative 3 is the same, positive 3. So in the first equation, if you subtract by 1 from both sides, the first answer is 2, and for the second one, negative 3 minus 1 is negative 4. So you get two answers for an absolute value equation. So now let's move on to fractions. If you want to add 5 plus 2/3, how can you do so? 5 is the same as 5 over 1. Whenever you want to add or subtract fractions, you need to get a common denominator. So the first fraction, let's multiply top and bottom by 3. Whatever you do to the top, you have to do to the bottom. So 5 times 3 is 15, 3 times 1 is 3. So now that we have common denominators, we can add the numerators. 15 plus 2 is 17, and so the answer is 17 over 3. Now, what if we wish to multiply two fractions? If you want to multiply two fractions, you multiply across. 3 times 5 is 15, and 2 times 6 is 12. And now we can reduce it. Let's divide top and bottom by 3. 15 divided by 3 is 5, 12 divided by 3 is 4. So the answer is 5/4. So when you're multiplying fractions, you can multiply across. What about if we wish to divide two fractions? There's something called keep, change, flip. You can keep the first fraction, change division to multiplication, and flip the second fraction. So 8 times 3 is 24, and 4 times 5 is 20. So let's divide top and bottom by 4 to reduce the fraction. 24 divided by 4 is 6, 20 divided by 4 is 5, so the final answer is 6 over 5. Now let's say if we have a fraction with large numbers. Now we can multiply across. However, we're going to get bigger numbers, and then we'll have to reduce the fraction. So if you're dealing with large numbers, simplify first before you multiply. So 8, we can rewrite 8 as 4 times 2, and 20 is 4 times 5. 15 is 5 times 3, and 12 is 4 times 3. So notice that we can cancel a 5, and we can cancel a 4, and we can cancel a 3. So right now what we have is 2 divided by 4, which we can reduce that further if we divide both numbers by 2. So then the final answer is 1/2. So we don't need to know what 8 times 15 is, or 20 times 12. So if you're dealing with fractions, simplify first before you multiply if you're dealing with large numbers. You can do so for small numbers too, but for small numbers you don't really need to. But for large numbers, you can solve it faster if you simplify it first. So now let's say if you have two fractions separated by an equal sign, how can you solve for the value of x? Whenever you have two fractions separated by an equal sign, you can cross multiply. So 3 times 4 is 12, and 5 times x plus 2 is 5x plus 10. So solving for x, let's subtract both sides by 10. So 2 is equal to 5x, and if we divide both sides by 5, x is equal to 2 over 5. So that's when you can cross multiply. So now let's move on to factoring. Let's say if we have a trinomial where the leading coefficient is 1. The leading coefficient is the number in front of x squared. If you want to factor an expression like this, find two numbers that multiply to 15 but that add to the middle term 8. So 1 and 15 multiplies to 15 but adds to 16. The other option is 3 and 5. 3 times 5 is 15, but 3 plus 5 is 8. And so when we factor it, it's going to be x plus 3 times x plus 5. And because factoring is a common technique that is needed on the SAT, let's do a few examples. So go ahead and factor this expression. So find two numbers that multiply to 28 but add to 11. So let's make a list. 28 divided by 1 is 28. If we divide it by 2 is 14. 3 doesn't go into 28, but if we divide it by 4 is 7. Notice that 4 plus 7 is 11. So it's going to be x plus 4 times x plus 7. So go ahead and try this example. X squared plus 3x minus 21. So let's make a list of the factors of 21. So we have 1 and negative 21. 2 doesn't go into it. 3 and negative 7. Actually, this one is not factorable. So let's change it. Let's make it x squared minus 4x minus 21. Actually, plus 4x minus 21. So notice that 3 plus negative 7 is negative 4. But if we change it to negative 3 and positive 7, it now adds to positive 4. So this will be x minus 3 times x plus 7. And that's how you would factor it. Try this one. X squared minus 9x plus 20. So what two numbers multiply to 20 but add to negative 9? So if they're adding to a negative result, we need two negative numbers if they're going to multiply to a positive number. So this could be negative 1 and negative 20, negative 2 or negative 10, negative 4 and negative 5, but these two add to negative 9. So it's going to be x minus 4 times x minus 5. But now let's say if the leading coefficient is not 1. Let's say if it's a 2. What can we do under these circumstances? The first thing we need to do is multiply the leading coefficient by the constant term. So 2 times negative 2, that does not look like a negative 2, is equal to negative 4. So you need to find two numbers that multiply to negative 4 but add to the middle term, negative 3. So this has to be negative 4 and positive 1. Negative 4 times 1 is negative 4, but negative 4 plus 1 is negative 3. So now what we need to do is we need to replace the middle term with negative 4x plus 1x. Notice that negative 4x plus 1x still adds up to negative 3x. So the value of the expression is still the same. It's just written in a different way. So now at this point, what you want to do is you want to factor by grouping. So you want to take out the GCF, the greatest common factor, in the first two terms. The GCF is 2x. Now to find out what's left over on the inside, divide. 2x squared divided by 2x is x, and negative 4x divided by 2x is negative 2. So now if we take out a 1, it's just going to be x minus 2 on the inside. If these two factors are the same, then you know you're on the right track. You haven't made any mistakes thus far. So now we're going to take out x minus 2. If we remove x minus 2 from this term, the only thing that's left over is 2x. And if we remove x minus 1 from this term, the only thing that's left over is plus 1. And so that's how you factor it. So let's try another example where the leading coefficient is not 1. Try this one. 6x squared plus 7x minus 3. So if we multiply 6 and negative 3, that is equal to negative 18. So we need to find two numbers that multiply to negative 18 but add to 7. So we have 1 and negative 18, 2 and negative 9, 3 and negative 6. Notice that 2 plus negative 9 is negative 7, but if we change it, negative 2 and positive 9 adds up to positive 7. So let's replace 7x with 9x minus 2x. The order doesn't matter. We could make it negative 2x and 9x. So now let's factor the GCF. The GCF for the first two terms is 3x. So 6x squared divided by 3x is 2x, and 9x divided by 3x is 3. Now if we factor out a negative 1 for the last two terms, negative 2x divided by negative 1 is 2x, negative 3 divided by negative 1 is plus 3. So because these two terms are identical, we know we are on the right track. And what goes in the next fraction is what we see on the outside, the 3x and a negative 1. And so that's how you can factor an expression or a trinomial where the leading coefficient is not 1. So now, let's talk about some other functions. Let's say if you want to factor x squared minus 25. How can you do it? Right now, this is in the form of a difference of perfect squares. So a squared minus b squared can be factored into a plus b and a minus b. So what you really need to do is take the square root of x squared, which is x, and the square root of 25, which is 5. One side is going to be positive and the other side is going to be negative. So let's say if you want to factor 4x squared minus 81. So what's the square root of 4x squared? We know the square root of x squared is x, and the square root of 4 is 2, so for 4x squared it's going to be 2x. And the square root of 81 is 9. So one is going to be positive and the other is going to be negative. Now, let's say if you want to factor 9x squared minus 64 y to the 4th. So what's the square root of 9x squared? That's going to be 3x. And the square root of 64, we know it's 8. And the square root of y to the 4th, what you basically do is take the exponent, divide it by 2. So it's going to be y squared. So it's going to be 8y squared. And on one side it's going to be positive and the other side is negative. So that's how you can factor using the difference of perfect squares method. So now there are some other things that you need to know. Let's say if you see an equation in this form, a squared plus 2ab plus b squared. This can be factored as a perfect square, a plus b squared. Likewise, if you were to see a squared minus 2ab plus b squared, this is equal to a minus b squared. So let's say if you get a question and they give you something like this, r squared minus 2rs plus s squared is equal to 49. What is the value of r minus s? Notice that r squared minus 2rs plus s squared, that's equal to r plus s squared if you were to factor it. So therefore, actually not r plus s squared, r minus s squared. It has to be negative. So if you factor it, it will be r minus s squared. So if you want to find r minus s, you simply have to take the square root of 49, which is 7. So let's say if you have this equation, x squared plus, well actually, let's say if you have x plus y is equal to 5, and you want to find the value of x squared plus 2xy plus y squared. You want to know what that's equal to. Well, if you factor this expression using the equation that we mentioned in the last page, this is equal to x plus y squared. So basically, you just have to square 5. 5 squared is 25. And so you might see a few questions like this on the SAT. Sometimes you have to square it, sometimes you have to square root it. You just got to know when you have to do what in each case. So now let's talk about solving equations that have fractions in it. So let's say if you have 5 plus 2 over x, and that's equal to 1. How can you solve for x in this equation? What I would recommend doing is multiply both sides by the common denominator. So there's only one denominator here, so let's multiply by x. So you got to multiply everything by x. 5 times x is 5x. 2 over x times x. The x variables cancel, so you're left over with 2. And 1 times x is x. So now what we're going to do is we're going to subtract both sides by x and subtract both sides by 2. So these, they will disappear. 5x minus x is 4x, and that equals to negative 2. So if we divide by 4, we're going to get negative 2 over 4, which is negative 1/2. And that's how you could solve for x. It's going to be a lot easier if you multiply both sides by the denominator. So let's try another example like that. Let's say if we have 3 over 2 plus 4 over x, and let's say that's equal to 3. So here we have two different denominators, 2 and x. So let's multiply both sides by the common denominator, which is 2x. So what's 3 over 2 times 2x, which is the same as 2x over 1? Notice that the 2's cancel, and what we have left over is 3 times x, which is 3x. And if we multiply 4 over x times 2x, the x's will cancel, and what's left over is 4 times 2, which is 8. So 2x times 3 over 2, we know it to be 3x. The 2's cancel. And 2x times 4 over x, the x's cancel, and we have 4 times 2 left over, which is 8. And then finally, 2x times 3 is 6x. So you have to multiply 2x by every term. If you miss one term, your answer will be incorrect. It's going to be wrong. So make sure you multiply everything in the equation by 2x. So now we can solve for x if we subtract both sides by 3x. So therefore 8 is equal to 3x, and if we divide by 3, x is 8 divided by 3. So now let's move on into functions. Let's say that f of x is equal to 3x plus 5. If we wish to find the value of f of 2, how can we evaluate it? All we need to do is replace 2 for x. So 3 times 2 is 6 plus 5, that is equal to 11. So we could say that f of 2 is equal to 11. F of x is equal to y if x is the only variable inside of the function. So as you can see, 2 is the x value. The value on the outside is the y value. So using the same function, f of x is equal to 3x plus 5. What is the value of x if f of x is equal to 29? How can you find the value of x? So what we need to realize is that y is equal to 29. So therefore, the 3x plus 5, the outside part, is equal to 29. And so you set the whole thing equal to 29, and then you can solve for x. Subtracting both sides by 5, 29 minus 5 is 24. And if we divide by 3, 24 divided by 3 is 8, so x is 8. So keep in mind, if the value is on the outside, you could set the whole function equal to 29. If it's on the inside, you need to plug in for x. Now sometimes you might have a function that has two variables. Let's say if you have f of x comma y is equal to x squared plus 2y. What is the value of f of 3 comma 5? So we could see that x is 3 and y is 5. So therefore, it's going to be 3 squared plus 2 times 5. 3 squared is 9, 2 times 5 is 10, so the whole thing has a value of 19. But now let's say if f of 4 comma y is equal to 28. What is the value of y? So notice that in this problem, x is equal to 4, and the entire function is equal to 28. So we can say that 28 equals x squared plus 2y. And we know that x is 4, so we can plug in 4 for x. And let's make some space. So therefore, 4 squared is 4 times 4, which is 16. And if we subtract both sides by 16, 28 minus 16 is 12. And if we divide both sides by 2, 12 divided by 2 is 6. So y is 6. So that's how you can solve for a variable if you have a function with two variables. So now let's talk about composite functions. Let's say that f of x is 2x plus 1 and g of x is equal to x squared. What is the value of f of g of 2? A composite function is basically two functions where one function is inside the other function. In this case, g is inside of f. So what you should do is start with the part that's on the inside and then work your way towards the outside. So let's evaluate g of 2. So g of x is x squared, so g of 2 is 2 squared, which is 4. So because g of 2 is equal to 4, I can replace g of 2 with 4. So now I'm looking for f of 4. So I'm going to plug this into the function for f. So 2 times 4 plus 1 2 times 4 is 8, 8 plus 1 is 9, and that's the final answer for this composite function. So, we've covered a few basic topics that you'll need for the first lesson in this SAT course. So, we've covered factoring, solving equations, adding, subtracting, multiplying fractions, composite functions, and basically most of the stuff that you'll need for the algebra part of the test. So at this point, let's begin with a few multiple choice problems. Number 1, if f of x is equal to 3x squared minus 5x plus x cubed, then f of 4 is equal to. So for all of these problems that we encounter in this video, pause the video and try the problem yourself, and then see if you can get the answer. If you do it that way, you're going to get the most out of this video. So always try each question before you look at the solution. But let's begin. If you want to find f of 4, all you need to do is substitute x with 4. So everywhere we see an x value, we're going to replace x with 4. So now we just have to do some math. 4 squared, that's 4 times 4, which is 16. 5 times 4 is 20. And 4 to the third power, that's 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64. 3 times 16 is 48. And 48 minus 20, that's 28. And 28 plus 64 is equal to 92. So therefore, D is the correct answer for this problem. Number 2, if f of x is equal to x squared plus 7x plus 5, and f of x is equal to 35, then what is the value of x? So, what's the first thing that you would do to solve this problem? Now keep in mind, f of x is equal to y. So the number that's on the inside of f is equal to the value of x, and a number that's on the outside is equal to y. So when we see the equation f of x is equal to 35, the number on the outside is equal to y, and we're looking for x. So we have the equation y is equal to x squared plus 7x plus 5. And f of x and y are the same thing. They equal each other. And so now we can replace 35 with y, and now we got to solve for x. Whenever you see an x squared and an x variable with half the exponent, like x to the first power, it's a quadratic equation, and you may have to solve it either by using the quadratic formula, by factoring, or even by completing the square. So at this point, let's subtract both sides by 35. So now we have 0 is equal to x squared plus 7x minus 30. So now we need to factor this expression. What are two numbers that multiply to negative 30 but that add to 7? The two numbers are positive 10 and negative 3. 10 plus negative 3 is positive 7, but 10 times negative 3 is negative 30. So in its factored form, it's going to be x plus 10 times x minus 3. So now, what we need to do is set each one equal to 0. So if we set the first factor equal to 0, x plus 10 equals 0, we could subtract both sides by 10, so x is equal to negative 10. So that's one possible answer. The other answer, x minus 3 is equal to 0. If we add 3 to both sides, x is equal to positive 3. So out of all the answers that are listed, 3 is the right answer. Answer choice C. So that's it for this problem. Number 3, if 3x plus 8 is equal to 24, what is the value of 7x plus 3? So how can we figure this problem? How can we find the value of 7x plus 3? The best way to do this is to solve for x in the first equation and then plug in the value of x in the second expression. So let's start with the first equation. 3x plus 8 is equal to 24. So let's subtract 8 from both sides. So therefore, 3x is now equal to 24 minus 8, which is 16. So to solve for x, we need to divide both sides by 3. Therefore, x is equal to 16 over 3. So now we want to find the value of the expression 7x plus 3. So what we need to do is insert the value of x into this expression. So right now we have 7 times 16 divided by 3 plus 3. To add these two terms, we need to get common denominators. So we're going to multiply the second term by 3 over 3. Whatever you do to the top, you have to do to the bottom, so that the value of the fraction remains equal. So 3 is equivalent to 9 divided by 3. Now we need to know what 7 times 16 is. 7 times 16 is 112. So we have 112 over 3 plus 9 over 3. And if we add those two, 112 plus 9 is 121 divided by 3. So we can see that answer choice A is the right answer for this problem. Number 4. If the square root of 7 is equal to x minus 3, then x minus 3 squared is equal to. So how can we solve this particular problem? Now, we could try the approach that we used in the last problem, and that is solve for x in the first equation and then plug it into the expression on the right, into x minus 3 squared. We could do that, and that will work. It will give us the right answer, but we don't need to. If x minus 3 is equal to the square root of 7, then we could square both sides. Then x minus 3 squared must be equal to the square of square root 7. Now, square root 7 squared is simply equal to 7. Here's why. The square root 7 squared is the same as the square root 7 times the square root 7. This 2 on top means that we have two square root 7s that are multiplied to each other. The square root of 7 times the square root of 7 is the square root of 49, because 7 times 7 is 49. And the square root of 49 is 7. 7 times 7 is 49. So, therefore, x minus 3 squared is equal to 7. So B is the right answer. Now, let's just see what would happen if we solve it using the approach that we used in the last problem. So, starting with this expression, we could solve for x by adding 3 to both sides. So 3 plus root 7 is equal to x. So now we can try to find the value of x minus 3 squared. And so since x is equal to 3 plus the square root of 7, we could take that value and insert it for x. So this is going to be 3 plus root 7 minus 3 squared. So the 3's will cancel. And then what you have left over is root 7 squared, which we know to be 7. So both methods or techniques will work. So whichever technique you feel comfortable with, that's the one that you should use. So B is the right answer for this problem, and let's move on to the next one. Number 5. If 4x is equal to 12, what is the value of 3x minus 7 squared? So let's solve for x. So if 4x is equal to 12, we could find the value of x by dividing both sides by 4. So therefore x is equal to 3. So now in order to find the value of 3x minus 7 squared, we need to take the value of x and insert it into this expression. So it's going to be 3 times 3 minus 7 squared. 3 times 3 is 9, and 9 minus 7 is equal to 2. And 2 squared is basically 2 times 2, which is equal to 4. And so therefore, A is the right answer for this problem. Number 6. If x plus 4 squared is equal to 8x minus 10 squared, then the value of x is... So how can we figure this problem? Well, let's take the square root of both sides. But first, let's rewrite the problem. So x plus 4 squared is equal to 8x minus 10 squared. So we need to take the square root of both sides. When you square root a square, you need to keep in mind that the index number is 2. And so the 2's will cancel. And therefore, the square root will get rid of the square. And so we don't need the parentheses anymore. So what we have is just x plus 4 is equal to 8x minus 10. Now, what you need to keep in mind is that whenever you take the square root of a number, you can get a positive answer and you can get a negative answer. So for the negative answer, all we need to do is change one side of the equation, or multiply one side of the equation by negative 1. And then it's going to work. So let's start with the equation on the left. Let's subtract x from both sides. So we're going to have 4 is equal to 7x minus 10. So next, let's add 10 to both sides. 10 plus 4 is 14. So 14 equals 7x, and then we're going to divide both sides by 7. So 14 divided by 7 is 2. So 2 is one possible answer, but notice that it's not one of the choices. So therefore, we can't really use 2 as an answer. So now let's work with the other equation on the right. So first, let's distribute the negative to the right side. So negative 1 times 8x is negative 8x, and negative 1 times negative 10, if we distribute, that's going to equal to positive 10. So now, let's add 8x to both sides, and simultaneously, let's subtract both sides by 4. So this will cancel, and that will disappear as well. X plus 8x is 9x. And 10 minus 4 is equal to 6. So next, we need to divide both sides by 9. So therefore, we could see that x is equal to 6 over 9. And if you divide both numbers by 3, since they're both divisible by 3, you can get a reduced fraction. 6 divided by 3 is 2. 9 divided by 3 is 3. So x is therefore equal to 2 over 3, or 2/3. So B is the right answer for this problem. But let's check it. Let's prove that this value is indeed the right answer. So let's plug in 2/3 for x. So 2/3 plus 4 squared should equal to 8 times 2/3 minus 10 squared. So let's get common denominators. 4 over 1 is the same as 12 over 3. If you multiply top and bottom by 3, you'll get 12 over 3. And 12 divided by 3 is 4, so the value remains the same. Now, 8 times 2/3. 8 times 2 is 16, so we have 16 over 3. And 10 over 1, what we could do to get common denominators is to multiply 10 by 3 over 3. So 10 is the same as 30 over 3. 30 divided by 3 is 10. So now we can add the two fractions. So 2/3 plus 12/3 is equal to 14 over 3 squared. And 16 minus 30 is negative 14 over 3 squared. So on the left side, we have 14 over 3 times 14 over 3. That's what 14 over 3 squared means. Now on the right side, we have negative 14 over 3. So that means that we have two negative numbers. Negative 14 over 3 times negative 14 over 3. In both cases, 14 over 3 times 14 over 3 will be 196 divided by 9. And on the right side, two negatives make a positive. Negative 14 over 3 times negative 14 over 3 is the same answer, 196 over 9. So therefore, because the left side is equal to the right side, this equation is true. So we could see why B is the correct answer. So whenever you take the square root, just keep in mind you may have a positive answer and you may have a negative answer. So you need to check both to see which one is the right answer, or which one is the answer that's listed in this problem. Number 7. If 8 times the fourth root of x cubed minus 15 is equal to 49, then the square root of x minus 4 is equal to. So you might see a lot of problems like this on the SAT, where you have to solve for x in the first equation and then plug in x to the expression on the right side. Now, as you can see, the difficulty of these problems are increasing. The main idea is the same, but the steps that you need to take to solve for x might be different, might be longer, sometimes it's easier. It can vary. But just make sure you know your algebra. You gotta know your stuff. So let's start with number 7. Let's rewrite the problem first. So the first thing we need to do is we need to add 15 on both sides. So 49 plus 15 is equal to 64. Next, we need to divide both sides by 8. 64 divided by 8 is equal to 8. Now, how can we rewrite the radical, the fourth root of x to the third? How can we rewrite it as a fractional exponent? The fourth root of x cubed is equal to x raised to the 3/4. So let me give you another example. Let's say if you have the seventh root of x to the third. This is equivalent to x raised to the 3/7. So now, how can we solve for x for this equation that we have at this point? So we need to change the exponent from 3/4 to 1, because x is the same as x to the first power, or x raised to the 1. So in order to change it to 1, we need to raise both sides to the reciprocal of 3/4, which is 4/3. And whatever you do to the left side, you have to do to the right side. So when you raise one exponent to another, you have to multiply. For example, x cubed raised to the 5th power is equal to x to the 15. You multiply 3 and 5. So 3/4 times 4/3, the 4's cancel and the 3's cancel. So 3/4 times 4/3 is simply 1. So we have x raised to the 1st power is equal to 8 raised to the 4/3. So now, how can we find the value of 8 to the 4/3? What you want to do is you want to separate the 3 and the 4. 8 to the 4/3 is the same as 8 raised to the 1/3, which is raised to the 4th. Because 1/3 times 4 is 4/3. So the value of this expression is still the same. We just rewrote it in a different way. So if you want to find out the value of 8 to the 4/3, the first thing you should do is take the cube root of 8. The number on the bottom is the index number. That's the root. And the number on the top is like the exponent. You're going to raise it to the 4th power. But first, let's find the cube root of 8. The cube root of 8 is a number where, before I give you the answer, here's what you need to ask yourself. If you want to find the cube root of 8, find out what number times itself 3 times is equal to 8. So what times what times what is 8? The answer is 2. 2 times 2 times 2, 3 times is equal to 8. So the cube root of 8 is 2. So now we got to find out what 2 raised to the 4 is. 2 to the 4 is basically 2 times 2 times 2 times 2. 2 times 2 is 4. And the other 2's on the right side is also 4. So 4 times 4 is 16. So 2 raised to the 4th power is equal to 16. and therefore that's not the final answer yet. So we need to avoid the temptation of selecting an answer when we're not finished yet, because I was about to do that. So what we now have is the value of x. X is equal to 16. But our goal is not simply just to find the value of x. We want to find the value of this expression, the square root of x minus 4. So let's take the value of x and insert it into this expression. So the square root of 16 minus 4. The square root of 16 is 4, and 4 minus 4 is equal to 0. So C is the correct answer for this problem. Number 8. If 8 minus 4 over x is equal to x plus 4, which of the following is a possible value of x? So we just got to solve for x in this problem. So let's begin. What's the first thing that you think that we should do? How would you solve for x in this expression? Now, the first thing that I would personally do is I would try to eliminate any fractions before I try to solve for the equation. So notice that the denominator of this fraction is x. So I'm going to multiply both sides by x. So x times 8 is equal to 8x, and 4 over x times x is equal to 4 because the x values, they cancel. So we're just going to get negative 4. And then x times x is x squared, and x times 4 is 4x. So whatever you do to the left side, you have to do the same thing to the right side. So we can't just multiply one side by x and not do the same for the other side. So this is what we now have. Notice that we have a quadratic expression. We have an x squared and an x. So whenever you see that, what you want to do at this point is you want to move everything to one side and try to factor the expression, use the quadratic equation, or complete the square to solve for x at this point. So let's subtract both sides by 8x, and let's add 4 to both sides. So this is 0 right here. If there's nothing there, it's a 0. So these cancel. So on the left side, there's nothing left over, so it's a 0. So 0 is equal to x squared, and then 4 minus 8 is negative 4. 0 plus 4 is 4. So now, what we need to do is we need to factor this expression. So what two numbers multiply to positive 4 but add to negative 4? This is negative 2 and negative 2. Negative 2 times negative 2 is equal to positive 4, but negative 2 plus negative 2 is equal to negative 4. So, therefore, in its factored form, we have x minus 2 times x minus 2. So if we set x minus 2 equal to 0, and if we add 2 to both sides, we could see that x is equal to positive 2. So therefore, E is a possible value of x. Now, if you're having difficulty solving for x, what you could do is you can plug in each of these answers and see which one is true for the equation. So let me illustrate that technique. So let's say if you think 1 is a possible answer. You can plug in numbers if you're having difficulty solving for the equation. So 8 minus 4 over 1, we're going to replace x for 1, is equal to 1 plus 4. 8 minus 4 is 4, and 1 plus 4 is 5. So this is not true. The left side does not equal the right side, so therefore D cannot be a right answer. So now, let's try another value. Let's try E. We know the answer is E. So let's replace x with 2. So 4 divided by 2 is 2, and 2 plus 4 is 6. 8 minus 2 is also 6, so 6 equals 6. The equation is true, so therefore we know E is the right answer to this problem. So you can always fall back to that technique, that is basically looking at the answers and plugging it into the equation to see if it works. And sometimes that might be the best way to solve the problem. It all depends on which technique is faster. Whichever technique can help you get to the right answer quicker, that's the technique you want to do, because the SAT is a time test. You have to be able to solve the problem very quickly and accurately at the same time. Number 9. If 4x minus 5y is equal to 6, what is the value of 16x squared minus 40xy plus 25y squared? So how can we do this problem? Now don't worry, it might look difficult, but it's not. You need to be familiar with this equation. A plus b squared is equal to a squared plus 2ab plus b squared. So here's the proof. A plus b squared is the same as a plus b times a plus b. So if you were to FOIL this expression, a times a is a squared, and a times b is ab, and then b times a is also ab, and then b times b is b squared. So we can add the two terms in the middle, and that will give us ab plus ab is 2ab squared. I mean just 2ab. So therefore you need to realize that a is 4x in this problem and b is 5y. By the way, if there's a minus sign, it's a minus b squared. A minus b squared is a squared minus 2ab plus b squared. But it's very similar. So we can see that a is equivalent to 4x and b is equivalent to 5y. So therefore, if a is 4x, that means a squared is 4x times 4x, which is 16x squared. And if b is 5y, that means b squared is 5y times 5y, which is 25y squared. So then the middle term is 2 times ab. So 2 times 4x for a and 5y for b. So 4 times 5 is 20, times 2 is 40. So this is negative 40xy. So how is this going to help us to get the answer? So let's think about what this means. So what this means is that 16x squared minus 40xy plus 25y squared is equal to 4x minus 5y squared. That's what we know. And our goal is to find the value of 16x squared minus 40xy plus 25y squared. We want to find out what the left side is equal to. We don't know right now, but we need to use the right side to figure that out. Now we know that 4x minus 5y is equal to 6. So if that's the case, we can replace 4x minus 5y with 6. So therefore, the left side is equal to 6 squared, which is equal to 36, and that's the answer. So it's E. You just have to realize that by squaring 4x minus 5y, it equals to the value of 16x squared minus 40xy plus 25y squared. So therefore, all you have to do is square 6, and you'll get the answer. So this problem is not hard if you understand it. Once you understand it, getting the answer is easy. All you got to do is square 6, and that's it, you're done. But it's the understanding that you need. Once you understand what to do, then math becomes easy. Number 10. If r squared plus 2rs plus s squared is equal to 169, what is a possible value of r plus s? So notice that r squared plus 2rs plus s squared is in the form a squared plus 2ab plus b squared. And we know that is equal to a plus b squared. So make sure you understand how to factor using this formula, because it's going to be very helpful when you're taking your next SAT exam. So if this equation is true, therefore, we know that r squared plus 2rs plus s squared is equal to r plus s squared. And since r squared plus 2rs plus s squared is equal to 169, therefore, r plus s squared is also equal to 169. And our goal is to solve for r plus s. So what we could do at this point is take the square root of both sides. So on the left side, we now have r plus s, which is what we're looking for. And the square root of 169, is equal to plus or minus 13. So therefore, negative 13 is a possible value of r plus s. And that's the answer for this problem. So A is the right answer. Number 11. If the product of x squared minus 3x minus 10 and 3x squared plus 2x minus 1 is 0, then x could equal any of the following numbers except. So we're looking for the values that x cannot equal. So first, let's convert the sentence into an equation. So the product of x squared minus 3x minus 10, product means multiplication, and we're going to multiply this by 3x squared plus 2x minus 1. The product of these two terms is equal to 0, or these two expressions. So we're not going to FOIL this expression. That would be a terrible, terrible thing to do. What we should do is we need to factor each expression. So let's start with the one on the left. So what two numbers multiply to negative 10 but add to negative 3? So let's make a list. We have 1 and negative 10 and 2 and negative 5. 2 and negative 5 works. 2 times negative 5 is negative 10, but 2 plus negative 5 is equal to negative 3. So this is going to be x plus 2 times x minus 5. And if there's a 1 in front of x squared, once you get the two factors, you can simply write it in parentheses if you get these two numbers. Now, for the expression on the right, the leading coefficient does not equal 1, so we're going to have to factor by grouping. So there's going to be a little bit more work that's involved for that part. So I'm going to factor it on the left side first. The first thing you need to do is you need to multiply the leading coefficient, 3, and the constant term, negative 1. 3 times negative 1 is negative 3. And you need to find two numbers that multiply to negative 3, but that add to the middle term, 2. So what two numbers multiply to negative 3 and add to positive 2? Try it. So this is none other than positive 3 and negative 1. 3 plus negative 1 is 2. 3 times negative 1 is negative 3. So now what we're going to do is we're going to replace the middle term, the 2x, with positive 3x and negative 1x. So that's all we did so far. We replaced 2x with 3x minus 1x, because 3x minus 1x is still equal to 2x. It's simply expressed differently, but the value is still the same. So now we're going to factor by grouping. In the first two terms, factor out the GCF, the greatest common factor. The greatest common factor is 3x. You can take out a 3x from 3x squared and 3x. That's the most, or the greatest, that you can factor out. When you factor out 3x from 3x squared, what's left over? To find out what's left over, divide. 3x squared divided by 3x is x. And 3x divided by 3x is 1. So now we're going to factor out a negative 1. Negative 1x divided by negative 1 is positive x. Negative 1 divided by negative 1 is positive 1. Once you see that these two factors are identical to each other, you know you're on the right track. So now we're going to factor out x plus 1. If we take out x plus 1 from this term, we have 3x that's left over. And if we remove x plus 1 from this term, we have a negative 1 that's left over. So therefore, the expression on the right can be factored to x plus 1 times 3x minus 1, and all of that is equivalent to 0. So now we can solve for x. So we can set each factor equal to 0. If we set x plus 2 equal to 0, x will equal negative 2. All you need to do is reverse the sign. If x minus 5 is equal to 0, then x is equal to positive 5. And for this one, it's negative 1. Now, if 3x minus 1 is equal to 0, to solve for x, we need to add 1 to both sides. And then we need to divide by 3. So x is therefore equal to 1/3. So those are the 4 possible values for x. Now we're looking for the exception. So we could eliminate answer choice A, we could eliminate B, we could eliminate C, and we could eliminate D. Because we have those 4 answers, negative 2, 1/3, negative 1, and 5. So the exception is E. X does not equal 3 in this equation. So therefore E is the right answer for this problem. In the factorable expression x squared plus kx plus 24, k is a positive integer. Which of the following is not a possible value of k? So, we need to find what value of k will not allow this expression to be factorable. So this is like a product sum type problem. We need to find two numbers that multiply to 24 but add to k. But how can we do that if we don't know what k is? So first, let's make a list of all the possibilities. All of the two numbers that multiply to 24. So this would be 1 and 24, 2 and 12, 3 and 8, 4 and 6. Each of these pairs of numbers multiply to 24. 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24. So now what we're going to do is we're going to add each of these numbers. Because k is the sum, 24 is the product, but k is the sum. 1 plus 24 is 25. 12 plus 2 is 14. 3 plus 8 is 11. And 4 plus 6 is 10. So therefore we could eliminate d because k could be equal to 10. 6 times 4 is 24, but 6 plus 4 is 10. And so if k was 10, we could factor that expression. If k was 11, we could factor it as well. And if k is 14, we can factor it as well. However, if k is 7, we can't factor it. If we had x squared plus 7x plus 24, this expression is not factorable. What two numbers multiply to 24 but add to 7? We've already made a list of all the numbers that multiply to 24, and that's it. If k was 10, we could factor this expression. X squared plus 10x plus 24 would be equal to x plus 4 times x plus 6. And so that's why 10 is not the answer. And because there's no two numbers that multiply to 24 but add to 7, therefore 7 is not a possible value of k. And so answer choice A is the right answer for this problem. 13. How can we find the value of x in this expression? So what's the first thing that you would do? The first thing that we should do is we need to factor each expression. So let's start with the expression on the upper left side. How can we factor x squared minus 2x minus 24? The first thing we need to do is we need to find two numbers that multiply to negative 24, but that add to negative 2. And so this is going to be 6 and 4. But which number is going to be negative? Is it the 6 or the 4? It has to be negative 6 and positive 4. Negative 6 times positive 4 is negative 24, and negative 6 plus 4 is negative 2. So we can factor it or write it as x minus 6 times x plus 4. Now we need to factor this expression as well. What two numbers multiply to 12 but add to positive 7? This has to be 4 and 3. 4 times 3 is 12, 4 plus 3 is 7. So it's going to be x plus 3 times x plus 4. So now we need to factor x squared plus x minus 6. So what two numbers multiply to 6 but add to positive 1? This is 3 and negative 2. So this is going to be x plus 3 times x minus 2. So the first thing we need to do is we need to simplify the expression. Notice that we can cancel x plus 4. And if we multiply the right side and the left side by x plus 3, these terms will cancel, and the same is true for those terms. So what we now have left over on the left side is simply x minus 6, and on the right side 12 divided by x minus 2. So now what we need to do at this point is put this over 1 and cross multiply. So 1 times 12 is 12, and we can FOIL x minus 6 and x minus 2 if we multiply those two. So foiling x minus 6 and x minus 2 is going to be x squared minus 2x minus 6x, and then 6 times 2 is 12, so plus 12. So at this point, we can combine like terms. Negative 2 and negative 6 is negative 8. And now let's subtract both sides by 12. So therefore 0 is equal to x squared minus 8x. So we're going to factor out an x. So 0 is equal to x times x minus 8. And so therefore x can equal to 0 and x can equal to 8. Anytime you see an x on the outside like this, x can equal to 0. So therefore, we're looking for a possible value of x. So E is the right answer. X could equal 8. 14. 4b is equal to 64. Then the square root of b times the cube root of 4b is equal to. So if 4b is equal to 64, then b is equal to 16 if we divide both sides by 4. 64 divided by 4 is 16. So now we can find out what the value of this expression is equal to. So let's plug in 16 for b. The square root of 16 is 4, and 4 times 16 is 64. And the cube root of 64 is a number times a number times a number that equals 64, and that's 4. 4 times 4 times 4, 3 times is 64. And 4 times 4 is 16. So C is the correct answer for this problem. 15. If x plus y is equal to 8 and x minus y is equal to 4, what is the value of x squared minus y squared? So what we need to do is solve for x and y, and then we could plug it in to the expression x squared minus y squared to get the answer. So let's line up these two equations, and notice that we can solve it by using the process of elimination. So if we add the two equations, x plus x is 2x, y plus negative y is 0, so they cancel, and 8 plus 4 is 12. So if we divide both sides by 2, 12 divided by 2 is 6. And so now what we can do is we can plug in 6 into the first equation. So 6 plus y is equal to 8. Subtracting both sides by 6, y is equal to 2. So now we can plug in x and y into this equation. So x squared minus y squared, that is equal to 6 squared minus 2 squared. 6 squared is 36, 2 squared is 4, and 36 minus 4 is equal to 32. And therefore B is the right answer for this problem. 16. If 2x plus 3y is equal to 13 and 4x minus 5y is equal to negative 7, then y minus x is equal to. So this problem is similar to the last problem. So let's use elimination to solve it. But let's line up the two equations. So 2x plus 3y is equal to 13. And 4x minus 5y is equal to negative 7. Now, let's multiply the first equation by negative 2 so that we can get negative 4x, and then we can add the two equations. So negative 4x, and then 3y times negative 2 is negative 6y. 13 times negative 2 is negative 26. So let's add the first these two equations. If we do that, 4x and negative 4x will cancel. Negative 5 and negative 6, if you add them, it's negative 11. And negative 7 plus negative 26 is negative 33. If we divide both sides by negative 11, y is equal to positive 3. So now we can solve for x using the first equation. So 2x plus 3y, or 3 times 3, since y is 3, is equal to 13. So 3 times 3 is 9. And 13 minus 9, if we subtract 9 on both sides, 13 minus 9 is 4. And then 4 divided by 2 is 2. So we have 2 for x, 3 for y. So the expression y minus x is therefore equal to 3 minus 2, which is equal to 1. So 1 is the answer for this problem. 17. If x times y is less than 0, which of the following must be true? So in this problem, let's try to disprove every statement. The one that we cannot disprove is the one that must be true. So let's choose two values for x and y such that the product is equal to a negative number, because the product xy has to be less than 0, which means it has to be negative. So let's try positive 5 for x and negative 4 for y. So looking at equation 1, well, first, xy must be less than 0. So 5 times negative 4 is less than 0 because negative 20 is less than 0. So 5 and negative 4 works. It's true for this equation. So now we can test each of the choices to see which one is true. So let's focus on x plus y. So if x is negative 4 and if x is negative 5 and y is 4, is it equal to 0? Negative 1 does not equal 0. So therefore, we have disproved number 1. So that means the answer can't be A and it can't be C. So now, let's look at statement number 2. 3x minus 3y is less than 0. So 3 times 5 minus 3 times negative 4. Let's see if it's less than 0. 3 times 5 is 15, and 3 times 4 is 12. 15 plus 12 is, that's 27. 27 is not less than 0. 27 is greater than 0, so that statement is false. So 2 is eliminated. So that means it can't be B and it can't be D. So the answer has to be E. But let's try it just to make sure. So x squared plus y squared is greater than 0. Well, x squared will always be a positive number, and y squared is always positive, unless you plug in 0. If you plug in 0 for x, then it's just 0. If you plug in a negative number for x, like negative 2, when you square it, it's going to be positive. So we can see why number 3 is going to be a true statement. A positive number plus a positive number is going to be greater than 0. And we can't use 0 for x and y, because let's say if we chose 0, 0. 0 times 0 is not less than 0. It equals 0. So we can't use 0 for x or for y. So which means x and y has to be a number other than 0, which means number 3 will always be true. So if we plug in 5 and negative 4, we're going to get 25 plus 16, which is greater than 0. And let's say if we choose a different test point. Let's say x is a negative number and y is a positive number. Negative 3 squared plus 5 squared will also give us a positive result. This is 9 plus 25, which is also greater than 0. So we cannot disprove number 3, which means 3 must be true. So therefore E is the right answer. 18. If x is greater than 0, which of the following is equivalent to the square root of x to the 5th power? So let's go over some rules associated with exponents. X squared times x to the 3rd is equal to x raised to the 5th power. When you multiply common bases, you need to add the exponents. And x squared raised to the 3rd is equal to x to the 6th power. When you raise one exponent to another exponent, you need to multiply the two exponents. So now we can answer the question. So the square root of x to the 5th is equal to, how can you write that as a fractional exponent? Keep in mind the index number, if it's not written, it's always assumed to be a 2. So this is x to the 5 over 2. So we need to find out which expression is equal to this one. Looking at number 3, x raised to the half raised to the 5th power. When you raise one exponent to another exponent, you got to multiply. So 1/2 times 5 is the same as 1/2 times 5 over 1, and that's 5 over 2. So number 3 is equivalent to this expression. So 3 is true. Now let's look at number 2. X to the 4th power times x to the negative 3 over 2. When we multiply common bases, we need to add the exponents. So therefore, we need to add four and negative 3 over 2. So let's get common denominators. Let's multiply this fraction on the left by 2 over 2. So this is equal to 8 over 2 plus negative 3 over 2. 8 minus 3 is 5. So this expression is equal to x raised to the 5 over 2. So number 2 is a true statement. So we can eliminate answer choice A, C, and D because they don't have number 3, which we know to be true. So at this point, we know 2 and 3 is true. So we can clearly see that B is the answer without even looking at number 1. Now, number 1 is not true. Let's say if you have x squared plus x cubed, this will not equal x to the 5th power. You can't add unlike terms. So x squared plus x to the 1/2 does not equal x to the 5 over 2, but let's prove it. So let's plug in a test point. Let's plug in 2 for x. Actually, not 2. Let's plug in 4. What is the value of 4 raised to the 5 over 2? This is the same as 4 raised to the half raised to the 5th power. So anytime you raise something to the 1/2, it's like finding the square root of that number. So the square root of 4 is 2, and 2 raised to the 5th power, that's 2 times 2 times 2 times 2 times 2, 5 times. 2 to the 5th power is 32. Now, if we plug in 2, will we get the same answer or will we get something different? 2 squared plus 2 raised to the half. 2 squared is 4, and 2 to the half is the square root of 2. The square root of 2 has a decimal value of about 1.4, so this is equal to 5.4, which is not equivalent to 32. Therefore, number 1 is not true, or it's not equivalent to x raised to the 5th 5 over 2 power. So therefore, E Well, not E, but B is the right answer. Only statements 2 and 3 are true. 19. If C is equal to 4 raised to the x, where x and c are both integers, which of the following expressions is equivalent to 16 raised to the x plus 4 raised to the x plus 2 power? So, how can we do this? So if we look at our answer choices, everything is in terms of c. So somehow we need to exchange x for c. So we need to do some algebra here. Let's start with the expression 16 raised to the x plus 4 raised to the x plus 2. Now, we can rewrite 16 as 4 squared. In order to convert x into c, we need the base 4. So let's convert 16 into base 4. So 16 is 4 squared. Now, last time we went over this property of exponents, we said x squared times x cubed is x to the 5th power, which is the same as x raised to the 3 plus 2. So what we want to do is we want to take an expression in this form and separate it into an expression that looks like what we have on the left. So therefore, if x raised to the 3 plus 2 power is equal to x squared times x cubed, then this expression, 4 raised to the x plus 2 power, is the same as 4 to the x times 4 squared. Because when you multiply common bases, you can add the exponents. So x plus 2 is the same as, or 4 raised to the x plus 2 is the same as 4 to the x times 4 squared. We can add x and 2 to get x plus 2 if we go backwards. So you need to understand that property of exponents in order to go from this step to this step that we have here. So now 4 raised to the 2x is the same as, or 4 squared raised to the x is the same as 4 to the 2x. Whenever you raise one exponent to another, you can multiply the two exponents. And 4 squared is 16, so what we have is 16 times 4 to the x. Now, instead of writing this as 4 to the 2x, I want to write it as 4 raised to the x squared. Notice that these two expressions are equivalent. 2 times x is the same as x times 2. So 4 squared raised to the x is the same as 4 raised to the x squared. Now the reason why I chose to write it that way is because at this point we can now replace 4 raised to the x with c. So this is equal to c squared plus 16 times c. So now we're going to factor out c. C is the GCF. So if we take out c, c squared divided by c is c, and 16c divided by c is 16. So we get c times c plus 16. So therefore, answer choice A is the correct answer for this problem. Number 20. If the equations above are true, which of the following is a possible value of y minus x? So, let's solve for x. If the absolute value of x plus 2 is equal to 7, what is the value of x? Whenever you have an absolute value equation, you can write two equations from it. The first equation is x plus 2 is equal to positive 7, and the second equation is x plus 2 is equal to negative 7. The reason why we can do that is because the absolute value of positive 7 is positive 7, and the absolute value of negative 7 is also positive 7. And so that's why we can separate into two equations. So for the equation on the left, if we subtract both sides by 2, x is equal to positive 5. And for the second equation, if we subtract both sides by 2, x is equal to negative 9. Negative 7 minus 2 is negative 9. Now, for the other equation, the absolute value of y minus 3 is equal to 4. Now let's write two equations. Y minus 3 is equal to positive 4, and y minus 3 is equal to negative 4. So, if we add 3 to both sides, 4 plus 3 is 7, and negative 4 plus 3 is negative 1. So these are the possible values of x and y. So we need to see what combination will give us one of the answer choices that are listed here. So y minus x. Starting with 7, if we choose 7 for y, we can subtract 7 by the x value of 5, which is 2. So 2 is not listed as an answer. We can also take the y value of 7 and subtract it by the x value of negative 9. 7 minus negative 9 is positive 16. And that answer is not listed here. So now we've used up y. So now let's try the other y value. So if we use negative 1 as y, we can use positive 5 for x. So negative 1 minus 5 is negative 6. That answer is not there. So now if we use negative 1 for y, and then the other x value, negative 9, negative 1 minus negative 9 is the same as negative 1 plus 9, which is equal to 8. Now that answer is listed there. So 8 is a possible value of y minus x using these two equations. So as you can see, there are 4 possible values: negative 6, 2, positive 16, and 8. But only 8 was listed as one of our answer choices. So therefore 8 is the answer that we're looking for. So E is the right answer. (21) If 4c plus b minus a over 7 is equivalent to a, what is b in terms of a and c? So how can we do this? How can we find b in terms of a and c? So what we need to do is we need to solve for b. That's basically what the question is asking us to do. If we can isolate b on one side, then a and c will be on the other side of the equation. So let's start with the expression 4c plus b minus a over 7 equals a. Now the first thing I would like to do is get rid of the fraction. So I'm going to multiply both sides by 7. So I'm going to multiply every term by 7. 4c times 7 is 28c. And b minus a over 7 times 7, the 7's will cancel. And then we'll have just b minus a left over. And then a times 7 is 7a. So now I'm going to add a to both sides. So at this point, the a's cancel on the left. So what we now have is 28c plus b is equal to 8a. So now let's subtract both sides by 28c. So then b is equivalent to 8a minus 28c. So now at this point, we need to factor the GCF. What is the greatest common factor between 8 and 28? The greatest common factor is 4. 4 can go into 8 and 28. So if we take out a 4, 8a divided by 4 is 2a, and negative 28c divided by 4 is negative 7c. So therefore, we can see that a is the right answer to this problem. (22) If f of x is equal to 2x plus 5, and g of x is equal to the absolute value of 3 minus x plus 2, what is the value of g of f of 1? So here we want to evaluate a composite function. That's when one function is inside another function. So f is inside of g. So first, let's find out what f of 1 is equivalent to. So that means we need to plug in 1 into this equation. So let's replace x with 1. So 2 times 1 plus 5 is equal to 2 plus 5, which is 7. So therefore, f of 1 is equal to 7, which means that we can replace f of 1 with 7. So we're looking for g of 7 at this point. So g of 7 is equal to the absolute value of 3 minus 7 plus 2. 3 minus 7 is equal to negative 4. And the absolute value of negative 4 is positive 4. So 4 plus 2 is 6. So therefore, g of f of 1 is equivalent to 6, so C is the right answer for this problem. 23. If f of x is equal to the square root of 3 minus x for all values where x is equal to or less than 1, and f of x is equal to 5 minus x squared for all values where x is greater than 1, what is the sum of f of negative 1 and f of 5? So what we really have is a piecewise function. The function f of x can be broken into two pieces. It can equal the square root of 3 minus x, and it can equal 5 minus x squared, depending on the value of x. So the first equation is true when x is equal to or less than 1, and the second equation should be used when x is greater than 1. So the goal for this problem is to find the sum of these two function values. So let's start with f of negative 1. If we want to find out the value of f of negative 1, should we use the first equation or the second equation? So when is x equal to negative 1? In this interval or in this interval? We know that it has to be true for the first one because x is less than or equal to negative 1. So let's plug in negative 1 into the first equation. So it's 3 minus negative 1, which is the same as 3 plus 1, and that's 4, and the square root of 4 is equal to 2. So now, what about f of 5? Should we use the first equation or the second equation? 5 is greater than 1, so it's in the second equation. So it's going to be 5 minus 5 squared if we replace 5 for x. So 5 squared is 25, and 5 minus 25 therefore is negative 20. So now we can find the value of f of negative 1 plus f of 5 because we're looking for the sum of these two function values. F of negative 1 we know it to be 2, and f of 5 is negative 20. So 2 plus negative 20 is equal to negative 18, and so therefore B is the right answer for this problem. 24. Let f of x comma y be equal to y squared minus 5x. So if f of x comma 3 is equivalent to negative 21, what is the value of x? So we have a function that contains two variables, x and y. And so this is equal to y squared minus 5x. And now we know that f of x comma 3 is equal to negative 21. So notice that the value of y is equivalent to 3. So we know that y is equal to 3. So notice that the left side is equal to the left side of the second equation. So therefore, the right side of the first equation must equal the right side of the second equation. So we're going to set those two equal to each other. So y squared minus 5x is equal to negative 21. And we know that y is 3. So this will allow us to solve for x. 3 squared is equal to 9. And we're going to subtract both sides by 9. So negative 21 minus 9 is equal to negative 30. And so we're going to divide both sides by negative 5. So therefore, negative 30 divided by negative 5, that is equal to positive 6. And so D is the right answer for this problem because that's all we're looking for. We just want to know what is the value of x. 25. Let the function f of c comma d be equivalent to d squared plus cd minus c squared. If f3 comma e is equal to 61 and e is a positive integer, what is the value of e? So let's start with the first equation that we have. The function is equal to d squared plus cd minus c squared. And we know that f3 comma e is equal to 61. Now notice that C is equivalent to 3. And notice that D is equivalent to E. And also, the right side of the first equation is equal to the right side of the second equation. So we can therefore make the statement that D squared plus CD minus C squared is equal to 61. And we can replace D with E and C with 3. So instead of writing D squared, we're going to write E squared plus, and then we're going to replace C for 3, so 3 times, instead of writing D, we're going to write E again, and then minus C squared, or 3 squared, and that's equal to 61. So 3 squared, which is 3 times 3, that's equal to 9. So notice that we have a quadratic equation, E squared and E to the first power. So we might be able to factor it. If not, we can complete the square or use the quadratic equation. But usually, these types of problems are factorable because the quadratic equation takes too long. And if you're taking the SAT, you have to do everything fast. So let's subtract both sides by 61. So negative 9 minus 61 is equivalent to negative 70. So let's see if this expression is factorable. So what two numbers multiply to negative 70 but add to positive 3? So let's make a list. We have negative 1 and 70, negative 2 and 35, 3 doesn't go into 70, and 4 doesn't go into it either, but 5 goes into it 14 times. So negative 5 and positive 14. 7 goes into it, so negative 7 and 10, and this works. Negative 7 times 10 is negative 70, but negative 7 plus 10 is positive 3. So to factor it, it's going to be E minus 7 and E plus 10. So let's make some more space. So therefore, we can write two equations. E minus 7 is equal to 0, and E plus 10 is also equal to 0, which means E is equal to positive 7, and E is equal to negative 10. But notice that we have two answer choices, negative 10 and positive 7. Which one do we pick? Now, if we go back to the question, it said that E is a positive integer, so we can't use the negative value. So therefore, 7 is correct. Answer choice E is the right answer. E is equal to positive 7. 26. Let the function h be defined by h of x is equivalent to 7x plus 25. So if the square root of h of b over 4 is equal to 9, what is the value of b? So let's start with the inside part of h of b over 4. Notice that there's no multiple choice answers to select. So this is our free response problem because typically you'll see some of those questions on the SAT. So to find h of b over 4, we need to replace x with b over 4. So therefore, h of b over 4 is equivalent to this expression. So starting with this problem, we can replace the h of b over 4 with this expression. So what we now have is the square root of 7 times b over 4 plus 25 is equal to 9. So to get rid of the square root symbol, we need to square both sides. So now 7b over 4 plus 25 is equal to 9 squared. And 9 times 9 is 81. So at this point, let's go ahead and subtract both sides by 25. So 81 minus 25 is equal to, that should be about 56, but let me make sure my math is correct. And yes, it's 56. So now we can cross multiply. Whenever you have two fractions separated by an equal sign, you can cross multiply. 7b times 1 is 7b, and 56 times 4, that should be 224. So now let's divide both sides by 7. So 224 divided by 7 is equal to 32. And so that's the answer. B has a value of 32. 27. If f of x is equal to this expression, what is the value of f of x minus x? So f of x minus x is equal to the expression that f of x is equal to, that's 7x plus 5 over 3 minus 4x minus 7 over 3 minus x. So keep in mind, this portion is equal to f of x. So that's all we did. We replaced f of x with what it equals to, these two fractions that are subtracted to each other. So now let's see if we can simplify the expression on the right side. And let's just see what happens. So 7x plus 5 over 3, we can separate that into two fractions. That's the same as 7x over 3 plus 5 over 3. And we can separate 4x minus 7 into two fractions. But at the same time, we're going to distribute this negative sign. So it's going to be negative 4x over 3. And then negative times negative 7, that's going to be positive 7 over 3, and then minus x. So let's combine these two fractions because they're like terms. 7 over 3 minus 4 over 3 is basically 3x over 3. And we can combine these two. 5 thirds plus 7 thirds, 5 plus 7 is 12. So that's 12 over 3, and then minus x. Now, 3x divided by 3 is simply x, and 12 divided by 3 is 4. And then we have minus x. X minus x is 0, so the final answer therefore is 4. So f of x minus x is equal to 4. 28. If 5x is equal to 12y, and y over z is equal to 8 over 9, then x over z is equal to... So how can we do this problem? Well, what we need to do is we need to rearrange some variables. So we need an equation that has only x and z. So we need to remove y out of the equation. So in the first equation, let's solve for y. So if 5x is equal to 12y, if we divide both sides by 12, we're going to get an equation that states that y is equal to 5x divided by 12. Now, in the second equation, y divided by z is equal to 8 over 9. We can replace y with 5x over 12. But before I do that, I'm going to rewrite the equation like this. Y over z is the same as y over 1 times 1 over z, which is 8 over 9. So therefore, y over 1, which is basically y, we can replace that with 5x over 12 times 1 over z, and that's equal to 8 over 9. It's always better to separate this fraction into two fractions by multiplication rather than plugging this in directly. If you plug it in right now, it's going to look like this: 5x over 12 divided by z. And then you're going to have to fix that fraction. Now you have a complex fraction. So I wanted to avoid the formation of a complex fraction. And so what I did is I separate this into two fractions by multiplication, and it makes it so much easier. So now, let's continue with what we have at this point. So if we multiply 5x and 1, we're going to get 5x. And then 12 times z is just 12z. So right now we have this: 5x over 12z is equal to 8 over 9. So I just multiplied 5x in 1 and 12 in z. So our goal is to isolate x and z. We want x on top, z on the bottom. So we need to get rid of the 5 and 12. So let's multiply both sides by the reciprocal of 5 and 12, which is 12 over 5. So the 12s on the left side, excuse me, will cancel, and the 5s on the left side will also cancel. So therefore, we have x over z is equal to 8 times 12 over 9 times 5. Now we can multiply 8 and 12 to get 96, and 9 and 5 to get 45, but then we'll have to reduce the fraction. It's better if we reduce it now than reduce it later after we get a bigger number. So 9 is basically 3 times 3. The 5, we can't reduce that further. And 12 is 4 times 3. And 8 is basically 4 and 2, but there's nothing to cancel the 4 and 2, so we're going to leave it as 8. Notice that we can cancel a 3. So now what we have left over is 8 times 4, which is 32, and 3 times 5, which is 15. And so, as you can see, it's easier if you reduce the fraction first before you multiply. So now you don't have to worry about what 8 times 12 is. So if you don't know what 8 times 12 is, that's okay. You can still get the right answer if you can reduce it first and then multiply later. So that's it. 32 over 15 is the value of x divided by z. 29. If x plus y is equal to 30, and if z over x is equal to 4, and 1/2 z is 20, and x does not equal 0, what is the value of x plus z? So we got a lot of equations here. It might seem like a difficult problem, but it's not if you understand it. So in order to find the value of x plus z, we just need to solve for x and z and then add the two numbers. So notice that the first equation has two variables, so we can't solve for x or y if there's two variables unless we have another equation. And this equation has x and z, so we can't use the first two equations because now we have three variables, x, y, and z. However, if you look at this equation, it only has z, which means we can solve it. So let's start with that equation. So 1/2 z is equal to 20. So therefore, let's multiply both sides by 2. 2 times 1/2 is 1. So 1z is equal to 40, which means z is 40. So now let's move on to the second equation, the one that has z in it, because now that we have the value of z, we can solve for x. So z divided by x is equal to 4. And we know that z is 40, so we have 40 divided by x is 4. Let's cross multiply. I'm going to write 4 as 4 over 1. So 40 times 1 is 40, and x times 4 is 4x. So if we divide both sides by 4, 40 divided by 4 is 10, so x is 10. Now, notice that we don't need the first equation. We don't need the value of y. If we wanted to, y is 20. If x plus y is 30 and x is 10, 10 plus 20 is 30. But our goal is to find the value of x plus z. And so we know that x is equal to 10 and z is equal to 40, so 10 plus 40 is 50. And so 50 is the answer for number 29. Number 30. If f of x comma y is 2x plus y minus 3, what is the value of f comma 3 comma 4 comma 5? So, in order to find out the value of this composite function, or a function within a function, let's start from the inside and let's work our way towards the outside. So let's find the value of f of 3 comma 4. So if f of x comma y is equal to 2x plus y minus 3, then we can see that x is equal to 3 and y is equal to 4. So let's plug in 3 for x and 4 for y. So this is going to be 2 times 3 plus 4 minus 3. 2 times 3 is 6, 6 plus 4 is 10, and 10 minus 3 is 7. So therefore f of 3 comma 4 is equal to 7. So going back to this expression, we can now replace f of 3 comma 4 with 7. So we have now as f of 7 comma 5. So we need to find the value of this function now. So therefore we can see that x is equal to 7 and y is equal to 5. So in this equation, let's replace 7 for x and 5 for y. So 2 times 7 is 14, and 14, well, let's do 5 minus 3 actually. 5 minus 3 is 2, and 14 plus 2 is 16. So the final answer is 16 for this problem. So let's start with lesson 2. We're going to focus on the ability of converting a sentence into an equation. So let's go over a few concepts and then we'll work on some multiple choice problems. So let's start with number 1. 5 more than twice the value of y. How would you write an equation from that sentence? So 5 more, 5 plus, and then twice the value of y, that's 2y. And that's it. Number 2, the sum of 5 times the number and the square of the number is 8. So 5 times the number, let's call the number x. So 5x and the square of a number, which is x squared, and since we have the word sum, it's going to be plus. And then is the same as equal to, so is 8. Sally is 1 year less than 3 times as old as John. So Sally is, when you hear like less than and then after like 2 then 3 times, if you see it like that, the less than part comes after, not before. So Sally is 3 times as old as John, less 1. It's kind of backwards. Kara is 3 times the difference between the ages of Jeremiah and Susan. Let's start with the difference between Jeremiah and Susan. So that's J minus S. And then 3 times the difference. So 3 times J minus S. And that's equal to Kara's age. The sum of two numbers is 8. Let's say the two numbers is x and y. Sum means addition. And then the product, which means multiplication, is 5. So xy equals 5. Now number 6. The sum of half a number and twice another number is less than or equal to 9. So let's say the two numbers are x and y. So when we hear the word sum, we're thinking of addition. Half a number, let's say half of x, plus twice another number, 2 times y, is, which is usually an equal sign, but it's less than or equal to, so we're dealing with an inequality. Less than or equal to 9. So I just want to give you a little warm-up of how to convert sentences into equations. So make sure you develop this ability as best as you can, because to do well on the SAT, at least the math part, you need to be able to convert sentences into equations. But now let's go over some other concepts that you need to be familiar with. The first thing is averages. The average of a number is the total value of a number divided by the number of values. So let's say if you want to find the average between 10, 12, 14, 16, and 18. You will add these numbers up and then simply divide by 5. Now, sometimes you may need to know what the total value is. The total value is equal to the average times n. Let's calculate the average. 10 plus 12 plus 14 plus 16 plus 18 divided by 5 is 14. So the average is 14. Also, 5 times 14 is 70. And 70 represents the sum of the 5 numbers. So now, let's move on to consecutive integers. When you hear the word consecutive, what do you think of? An example of consecutive integers is a number that occurs right after another number. So consecutive positive integers would be like 7, 8, 9, 10. consecutive negative integers would be like -5, -4, -3. And then you need to know odd numbers and even numbers. Even numbers are like 2, 4, 6, 8, and so forth. Odd numbers are like 1, 3, 5. Now, if you hear the word consecutive even integers, that would be like 2, 4, 6, 8, 10, and so forth. Those are consecutive even integers. Now, you need to know the difference between whole numbers, natural numbers, and integers. An integer could be negative, it can be positive, or it can be 0. These are considered integers. A whole number includes 0 and positive integers. Natural numbers do not include 0, but they do include positive integers. So just in case you see these terms on the exam, you know what they mean. Now, when you hear the word multiple, what are multiples of 7? Multiples of 7 are 7, 14, 21, 28, 35, and so forth. Just in case you see these words in a sentence, you need to understand how to turn them into an equation, so you have to know what these words mean. Next in our list is the terms inclusive and exclusive. So let's say if you want to make a list of all the consecutive odd integers between 5 and 12, inclusive. So that would include 5, 7, 9, and 11. Those are the odd integers, and they're listed consecutively. And 12 is not odd, so it's not included. If it was exclusive, that means it doesn't include 5 or 12. So exclusive would be 7, 9, and 11. So if you want to find all of the odd integers between 5 to 12 exclusive, not including 5 and 12, it's 7, 9, and 11. So list all the integers between 1 to 7 inclusive and exclusive. So inclusive, that means including 1 and 7, so it's 1, 2, 3, 4, 5, 6, and 7. Exclusive, you're not including 1 and 7, you're excluding them out of the list, so it's going to be 2, 3, 4, 5, and 6. So now you know what these terms mean. The last thing you need to be familiar for the next few multiple choice problems that you're going to go into is the equation for distance, rate, and time. You've seen this equation many times. D equals RT. D represents distance. R represents the rate, which is usually speed, and T represents the time. So let's say if you have a car going at 30 miles per hour, what distance will it travel in 4 hours? If a car is moving at 30 miles per hour, what that means is that in 1 hour, it's going to travel a distance of 30 miles. So in 4 hours, it's going to cover a distance of 120 miles. And that's the idea between distance, rate, and time. By the way, make sure the units match. So if your rate is in miles per hour, the time has to be in hours. And so if the rate is in miles per hour, the distance has to be in miles. So the units have to match. If they don't match, make sure you convert one unit into the appropriate unit that's going to work in this equation. Alright, so that's basically it. So let's jump into some multiple choice questions, and let's get started. 31. If the average of x, z, and 70 is 10 more than the average of y, z, and 30, what is the value of x, y? So the equation for the average is equal to the total, or the total value, divided by the number of values. So let's say if we have three numbers, 10, 11, and 12. These numbers are consecutive, and if we wanted to find the average, it would be 10 plus 11 plus 12 divided by 3, which is equal to the number in the middle, which is 11. So that's how you find the average of a number. But now let's see if we can use that to solve this problem. So if the average of x, z, and 70, the average of those three numbers is the sum x plus z plus 70, like we did 10 plus 11 plus 12. And then because we have three numbers, the average is going to be the sum divided by 3. So x, z, and 70 is equivalent to equal is 10 more than the average of y plus z plus 30 divided by 3. So that's the equation that we have. Now, there are three variables, x, z, and y, and our goal is to find x minus y. We can't isolate and solve each variable. However, we could possibly get x and y by itself, and that's what we have to try to do here. Because if we have three variables, you can't solve for each variable unless you have three equations, and we only have one equation. So let's multiply everything by 3 to get rid of the fractions. So the fraction on the left times 3, the 3's will cancel, and so we're going to get x plus z plus 70 left over. And then we're going to multiply the 3 by 10, and so that's going to equal 30. And then the 3 times this fraction, the 3's will cancel, and so that will equal y plus z plus 30. So at this point, we can add like terms. And at the same time, we can subtract both sides by z. So the z variables will cancel, and 30 plus 30 equals 60. So right now we have x plus 70 is equal to 60 plus y. So if we subtract both sides by 60, what we now have is x plus 10 is equal to y. Let's move the 10 back to this side. So x equals y minus 10. And now let's subtract both sides by y. So then what we now have is x minus y is equal to 10. Well, negative 10. We can't forget about this negative sign. And so that's it. That is the value of x minus y. So B is the right answer for this problem. 32. If 5 more than 3 times the number is 15 less than that number, what is the number? So let's convert this question into an equation. So we have 5 more represents plus, 5 more than 3 times the number, we're going to call the number x, is the same as equals 15 less than that number. So it's the number minus 15. What is the number? So we just got to solve for x. Let's add 15 to both sides. So 20 plus 3x is equal to x. And so now let's subtract by 3x. So x minus 3x is negative 2x. And if we divide both sides by negative 2, we can see that x is equal to negative 10. So therefore, the number is negative 10. So A is the right answer. 33. The sum of 3 consecutive positive even integers is z. In terms of z, what is the sum of the first and second integers? So 5, 6, and 7 are integers, consecutive integers. They're positive, but they're not even. 5 is odd, 6 is even. But numbers like 8, 10, and 12, they're even integers and they're consecutive. So this is the pattern of numbers that we're looking for. So then, the sum of 3 consecutive positive even integers is z. In terms of z, how can we find the sum of the first and second integers. Feel free to pause the video and try this yourself. So let's say that the first integer is x. Therefore, the second one will have to be x plus 2. The second one is 2 more than the first one, and the third one is going to be x plus 4. So let's say if x was 8. 8 plus 2 would be 10, and 8 plus 4 is 12. So as you can see, these are consecutive positive even integers. Now, the question stated that the sum of these three consecutive even integers is equal to z. So that's the equation that we have. And somehow, with this equation, we need to find out what the sum of the first and second integers are in terms of z. So here's the first one, this is the second, and this is the third. So what we're going to do is we're going to solve for x in terms of z first. So x plus x plus x is 3x, and 2 plus 4 is 6. So 3x plus 6 is equal to z. And if we subtract both sides by 6, 3x is equal to z minus 6. And if we divide everything by 3, x is equal to z minus 6 over 3. So now let's save that answer. So now our goal is to find the sum of the first and the second integer. So the first integer, we know it's x, but in terms of z, we know that x is equivalent to z minus 6 over 3. So let's move this somewhere else. And the second one is x plus 4, so z minus 6 over 3 plus 2. So this is for the second integer. So now we can add these two terms together. Z plus z is 2z, and negative 6 plus negative 6 is negative 12 divided by 3. Now, we need to do something with the 2. So let's write it as 2 over 1, and let's try to get common denominators. So we're going to multiply the 2 by 3 over 3. So then this is going to be plus 6 divided by 3. Now, we can now add the numerators. So it's going to be 2z, and then negative 12 plus 6 is minus 6 divided by 3. So this is the sum of the first and second integers in terms of z. So therefore, D is the right answer to this problem. By the way, the video that you're currently watching is a 2-hour trailer version of a longer 6-hour video. So this video currently has the first lesson and part of the second lesson. But if you want access to all 6 lessons, I'm going to post a link and you can check out that 8-hour video when you get a chance. So let's continue working on the next problem. 34. If the remainder is 5 when a positive integer b is divided by 7, then what is the remainder when 9b is divided by 7? So before we solve this problem, let's go over an example situation. So let's say if we wanted to divide 37 by 7. So if we were to use long division, we can see that 7 goes into 37 5 times. And we can see that 2 is a remainder. So in fraction form, we know that 7 goes into 37 5 times, and the remainder is 2. And since we couldn't divide it by 7, we leave it as 2 over 7. Now to see why this works, 37 is the sum of 35 plus 2. Notice that the left side is equal to the right side. So 37 over 7 is 35 over 7 plus 2 over 7. And 35 over 7 is 5. And then the part that we can't reduce, we leave it as 2 over 7. So now let's go over another example. Let's say if we wanted to divide 9 into 49, or divide 49 by 9. 9 goes into 49 5 times, and since 5 times 9 is 45, the remainder is 4. But we write it as 4 over 9 because that's the part that we couldn't, because we tried to divide 4 by 9, but we couldn't. So we'll leave it as 4 over 9. So now let's see if we can apply this situation to this problem. But I wanted you to understand the process of dividing two numbers and getting the remainder. So, when a positive integer b is divided by 7, the remainder, which is this number, the remainder is 5, but we have to write it as 5 over 7. Now, we don't know how many times 7 can go into b, so we're going to say that the amount of times that 7 goes into b, we'll call it just n. Now, our goal is to find out what is the remainder when 9b is divided by 7. And that's what we want to do. So if we compare b over 7 to 9b over 7, basically it's simply 9 times its value. So let's multiply both sides of this equation by 9. So on the left, we're going to get 9b over 7, and we got to multiply everything by 9. So n times 9 is 9n, and then 5 times 9 is 45 over 7. So now notice that, let's focus on this part, 45 over 7. We can reduce that. 7 can go into 45. The question is, how many times? 7 can go into 45 6 times. And since 7 times 6 is 42, 45 minus 42 is 3, so 3 is the remainder. So we can rewrite this as 9b over 7. 7 goes into 9b at least 15 times. Well, or 15n, where n is the number of times it can go into. Well, maybe that's not really accurate. I should say 9n plus 6. There we go. Okay, that's more accurate. So 7 goes into 9b 9n plus 6 times, and the 3 is remaining. So all I did was I replaced the 45 over 7 with 6 plus 3 over 7. So that's why it's 9n plus 6 plus 3 over 7. And so the remainder is 3. So 3 is the final answer to this problem. So let's see if we can prove it. Think of a number in which 7 could go into, but the remainder is 5. So let's use 19. So we're going to say b is 19. So 7 goes into 19 2 times, and 7 times 2 is 14, and 19 minus 14 is 5. So here we got a remainder of 5. So now if we multiply 19 by 9, will the remainder be 3? So 19 times 9 is 171. So how many times does 7 go into 171? 7 times 24 is 168. So 7 can go into 171 at least 24 times. And 171 minus 168 is 3. So we could have rewritten this like this. 171 is basically 168 over 7 plus 3 over 7. 168 plus 3 is 171. And 168 divided by 7 is 24. So we get 24 and 3/7. Basically, you can convert this into a mixed number if you want. But as you can see, the remainder is 3. So therefore, C is the right answer for this problem. 35. A basketball team won 11 more games than it lost. If the team played a total of 81 games and there were no ties, how many games did the team lose? So for this one, we want to convert these sentences into equations. So let's start with this sentence, or this portion of the sentence. The team played a total of 81 games. So some games they won and sometimes they lost. So W plus L, the wins and the losses, should add up to 81 games since that's the total games that they played. Now, let's focus on the first sentence. Let's see if we can turn it into an equation. The team won 11 more games than it lost. So that means that W is equal to L plus 11. The number of wins is 11 more than the number of games that the team lost. So that's the equation for the first sentence. At this point, we have two equations and two variables. We can solve using the method of substitution or elimination. Since we have W on one side in the second equation, substitution is the best option. So let's replace W in the first equation with 11 plus L in the second equation, since they equal each other. So what we now have is 11 plus L is 81. So therefore 2L equals, or 2L plus 11 is equal to 81. So if we subtract both sides by 11, 2L is equal to 81 minus 11, which is 70. And if we divide both sides by 2, 70 divided by 2 is equal to 35. So that's how many games the team lost. They lost a total of 35 games. So C is the right answer. If you want to find how many games were won, you can use the first equation. So W plus L is 81, so W plus 35 is equal to 81. And 81 minus 35, that's about 46. So notice that 35 plus 46 adds up to 81. And 46 is 11 more than 35. So this is the answer for W and L, because at those values, equation 1 and equation 2 are true. But C is the right answer, so we're looking for the number of games that the team lost. 36. When 4 times the difference of a number n and 15 is divided by 3, the result is 12. What is the value of n? So let's turn this sentence into an equation. So 4 times the difference of a number n and 15. Let's focus on that part. The difference of a number n and 15. The difference between n and 15 is simply n minus 15. And it says 4 times the difference, so it will be 4 times n minus 15 in parentheses. And this is divided by 3. And when it's divided by 3, the result is 12. So the result means equal. So now our goal is to solve for n. So we can write 12 as 12 over 1. And since we have two fractions separated by an equal sign, we can cross multiply. So 3 times 12 is 36. And 1 times 4n minus 15 is 4n minus 60 if you distribute the 4. 4 times negative 15 is negative 60. So now let's add 60 to both sides. So 36 plus 60 is equivalent to 96. And now we need to divide both sides by 4. So 96 divided by 4 is 24, and that is the value of n. So E is the right answer. A certain sample of bacteria triples in number every hour. If there were 8 bacteria in the sample at the start of the experiment, how many bacteria were there after 6 hours? So initially, there was 8. And after the first hour, there's going to be 8 times 3, which is 24. And after the second hour, times 3, and then the third hour, and then the fourth, and then the fifth, and then the sixth. Every hour, it triples. So after 6 hours, it's going to be 8 times 3 raised to the 6th power. Now, 3 to the 6th power is about 729. So 8 times 729 is equal to 5,832. So that's going to be the amount of bacteria after 6 hours. So C is the right answer. 38. 3 bananas and 8 grapes cost $1.91. 14 bananas and 25 grapes cost $8.05. What is the cost of 8 bananas and 16 grapes? So we need to write two equations and solve for the number of bananas and grapes. Then we can find the cost of 8 bananas and 16 grapes. So let's begin. Let's start with the first sentence. So 3 bananas, or 3 times B, plus 8 grapes, 8 times G, has a cost, or is equal to $1.91. Now for the second equation, 14 bananas and 25 grapes costs $8.05. So these are the two equations. So now we need to solve for either B or G first. So let's solve for B. Let's multiply the first equation by negative 14. So, and then the second equation we're going to multiply by positive 3. So negative 14 times 3b is negative 42b, and 8 times negative 14, that's going to be negative 112g. And 1.91 times negative 14 is about negative 26.74. Now for the second equation, 14b times 3, that's positive 42b. 25 times 3 is 75 g. And 8.05 times 3, that's going to be positive 24.15. So if we add the two equations, these two variables cancel, and negative 112 g plus 75g, that's equal to negative 37g, and negative 26.74 plus 24.15, that's negative 2.59. So now we can solve for G. So if we divide both sides by negative 37, G is going to be, let's see, negative 2.59 divided by negative 37 is equal to 7 cents. So that's the cost of one grape. Now, using this equation, let's find the cost of a banana. So let's solve for B. 3b plus 8 times the value of a grape, which is 7 cents, is equal to $1.91. So 8 times 7 cents, that's going to be 56 cents. And $1.91 minus 56 cents, that's going to be $1.35 for 3 bananas. So therefore, if we divide that by 3, we can get the cost of a single banana. So each banana costs 45 cents. So now at this point, we could find the value of 8 bananas and 16 grapes. So 8b plus 16g. So let's plug in 45 cents for B and 7 cents for G. So 8 times 45 cents, that's going to be $3.60. And 16 times 7 cents, it's about $1.12. So $1.12 plus $3.60, that is equal to a total value of $4.72. So that's the cost of 8 bananas and 16 grapes, which is between the cost of 3 bananas, 8 grapes, and 14 bananas, 25 grapes. So B is the right answer. 39. If B is an integer that satisfies the inequality above, what is the sum of the largest possible value of B and the smallest possible value of B? So to get the smallest possible value of b, we can use this equation. 4 is less than the square root of b. And to find the largest possible value of b, we can solve this equation. The square root of b is at most 8. So therefore, let's square both sides for the first equation. So 4 squared is 16, and the square root of b but squared is simply b. And if we square the other side, b is less than or equal to 8 squared. 8 times 8 is 64. So therefore, what is the largest value of b? If b is less than or equal to 64, then the largest that b can equal is 64. Now, if b is greater than 16, what is the largest possible value of b? It is not 16. b has to be greater than 16. And b is an integer, so it can't be like 16.1. So b has to be greater than or equal to 17, because it has to be an integer, like 16, 17, 18. But since it's greater than 16, it can't equal 16, but it can equal 17. So our goal is to find the sum of the largest possible value of b and the smallest possible value of b. So the smallest value of b is 17, and the largest value of b is 64. 17 plus 64 is equal to 81, and therefore E is the right answer. Number 40. Bonnie is 5 years younger than Roger and 4 times as old as Dana. If Dana is D years old, how old is Roger in terms of D? So let's start with the first part of the sentence. Bonnie is 5 years younger than Roger. How can you write an equation between Bonnie and Roger? So therefore Bonnie is Roger's age but minus 5. So if Roger's like 40, Bonnie would be 35. 40 minus 5 is 35. So therefore Bonnie would be 5 years younger than Roger if Bonnie was 35 and Roger was 40. Now, Bonnie is 4 times as old as Dana, so B equals 4D. So if Dana's like 8, 4 times 8 is 32, Bonnie would be 32. So now if Dana is D years old, how old is Roger in terms of D or Dana? So what we need to do is get an equation and solve for R in terms of D. So notice that B is equal to R minus 5 and B equals 4D. So since we know that B equals B, we can replace B with R minus 5 on the left side, and on the right side we can replace B with 4D. So now we can solve for R. So if we add 5 to both sides, R is equal to 4D plus 5. So Roger is 4 times as old as Dana plus 5. So let's say if Dana is 10 years old. That means Bonnie is 4 times her age, so Bonnie is 40. And Roger is 4 times Dana age plus 5. So 40 plus 5, Roger's 45. And he's 5 years older than Bonnie, or Bonnie is 5 years younger than Roger. So we can see how the numbers work out here. But the answer that we're looking for is how old Roger is in terms of D. So Roger is 4D plus 5. So therefore A is the right answer to this problem.